Hello and welcome to a new edition of Ozen Engineering videos. In this video I'm going to talk about Ansys Icepak and I'm going to focus on modeling of thermoelectric coolers. For this purpose I'm going to unpack an existing model which essentially has a board and an IC package on top of it. And we're going to put a TEC and heat spreaders on top of our IC package to spread out the heat. So let's go ahead, double click on our board element and look at the dimensions, look at its properties. So that looks right. Also, let's expand our package. Double click on the package, and here let's check our dimensions. So those also do look good. We want to also make sure we have some power, about 25 watts. So that's great. So now we're gonna be heating up the system. Next step, we're just gonna put a conducting plate over the package, and we're gonna call it, a heat spreader, essentially just to conduct the heat away. So for that purpose, I'm gonna go hit the Create Blocks button, which is going to bring up a window where, and when I double click on it, where now I can define the sizing of it. Let's hit update and then visually confirm that it sits on top of the package. As the next step, we're going to add our TEC. So let's go to Libraries, under Icepak. Let's go under Thermoelectric Coolers, and I'm going to pick this particular one and just double click, which is going to place our object out here. And as you can notice, it's not obviously in the correct position. So what we want to do is we want to right click on our new object and we want to move it. So here we want to do a rotation and a translation. So let's rotate it about the x-axis for 90 degrees, and let's put in some offsets. So here, note that sometimes the units may be different, so you want to be careful with them. And let's hit apply and done. So as you can see, this essentially moved our TEC into the correct position close to the heat source. Now let's go ahead and add our second conducting plate, or our heat spreader. So let's create blocks, and then let's double click on our block here, and this one's again, let's resize our block. This, so hit update and done. Let's take a view. Let's make sure everything is aligned properly. In the next step, I'd like to define some thermal boundary conditions. And I'd like to do that by defining a wall at the bottom here along this blue line. So I'm going to go ahead, click the Create Walls button, and then double click on it. Now let's place our geometry. It should be in the parallel Y direction. And then let's define it at the all the way across, and then at the fixed Y location, and hit update. So that essentially just jumped on this bottom face. And now I want to edit its thermal properties, and what it's going to have a thickness of 0, and I'd like to define heat transfer coefficient, and the value is going to be 15 watts per meter square at the ambient temperature. And I'll hit update, done, and then done. Let's create a second object that will go on top. And then here, let's double click on this again. Let's define its location. So it will be same dimensions as the previous one, but now place that on the top side. Let's hit update, and you can see that line just got thickened. So we have it in the correct location. And now let's define the thermal boundary condition. So we're going to use a fixed wall temperature of ambient, which is 20 degrees C. Okay, now what we can do is we can go to cabinet, do an auto scale. So now you can see the blue lines are here. We've defined our domain with thermal boundary conditions in the Y-min and Y-max locations. And we also defined our geometry and the power. So before I go any further, what I just noticed is I mistakenly placed block 1 into the package, and looks like I cannot move it. So what I'm going to do is I'm going to delete this object, and for clarity, I'm gonna rename this as heat spreader 2. And then I want to add other block and edit. I'm going to call this heat spreader 1 and redefine its geometry. And hit update. Let's make sure we have our dimensions right. Our heat spreader maybe looks a little too large. Let's make sure that it is the right size. Okay, now we see that that one's correct, heat spreader 2 is correct, and they're in the right location in our physical tree. Now I'd like to go ahead and do the meshing, and for this purpose we are going to use mesh assembles separately. So we're going to look at our assemblies. What we're going to do is first we're going to pick our layered assembly, and we're going to click edit. We're going to hit create assembly. So now let's rename these as TECs, and let's go to meshing. We want to mesh this separately and define its own slack settings. So let's use these values near 1 millimeter. For our slack settings. And let's hit update, and done. Our next step is, let's go to our package, double click on it. We want to do a separate mesh on this as well. Let's use the same values, which is auto-filled for us. Then let's not use global mesh settings, but let's use these settings right here. And then hit update, and done. So next step is actually generating the mesh. What we want to do is go to the top panel and select this mesh button here. And then let's make sure have the reasonable maximum, minimum gap and maximum element size values. And we can go ahead and click generate. So as you can see on the top right corner, the geometry is being meshed right now, so sometimes this may take some time. In this particular case, probably not a long time because it's a fairly simple model. And what we see is now our mesh is generated. And what we can do is let's take a look at our mesh. Let's turn on display mesh. Let's pick a surface, or let's pick a cut plane. And what you can see is, you know, all the details resolved pretty well for the geometry. Let's make sure our face alignment and skewness have good values, and they do, which is great. So we can close this window. Before executing our model, it's always recommended to put some monitor points where you can track properties. So we're going to go under package, take this object, and then put it under points. So this is going to create a monitor point for us. Similarly, let's go ahead, pick our TEC code object and place it under points. As default, whenever you have a monitor. If you don't change it, it's going to show the temperature. Next step, let's start defining our problem. So we go on our tree to problem setup, double click on basic parameters, and what we want to do is just do a temperature calculation. We're not going to deal with radiation because there's no flow. It doesn't matter if it's laminar or turbulent, so we can hit accept. It is always a good practice to save your model before running, just in case if there's some problem with the execution. So you want to click Save Object, which is going to do saving, and in the messages below it's going to say Done Saving. Now, one difference with running a thermoelectric cooling case is we're not going to go use the Run Solution button. We're going to use the Run TEC macro. So this is very important. What you want to do is go under Macros, under Modeling. Let's see, so let's try to find it. So it is under Modeling, Thermoelectric Cooler, and then Run TEC. So let's pick the Run TEC option, and this is going to do the execution for us. So in this case we can just use layered properties. Another option might be to define these material property coefficients. We do want to specify I and calculate T. So let's specify our current as 1.5 amperes. And we can leave the G factor and the TEC couples as the same. So we can give the run name here. We can leave it at that. And then now we just hit accept. And the macro is going to automatically go through the rest of the process, submit the job to Fluent to execute, and then we'll come back for post-processing once the macro is completed. As you can see, the execution is now complete, where we see the monitor the temperatures at our two locations, and we see that solution is converged, is not changing. It converged in a quick 6 iterations. So we can click done, and then as you can also see at the console here, it's done loading the solution. What we want to do at this point is take a look at the solution. Typically we want to use these buttons here. Let's do a plane cut, and that is going to bring up the plane cut panel. Let's take a look at the Z plane through the center. We want to look at the contours, so turn that on. Click parameters. We're interested in the temperature, and then let's look at the object limits. Let's hit apply. Let's see what our temperature field looks like. What I'm going to do is to hide these objects. So let's do this. So let's go hide our package. PCB. Now we can see the entire cross section where we have our high temperatures on the package, but then heat is getting essentially conducted away with our TEC. As a next step, if we wanted to get some numerical values, what we can do is go on the report. Let's select summary report, which is going to bring up a new panel where let's pick report facet values, and then let's pick some objects. Let's see, let's pick our TEC ceramic button, top, TC cold, TC hot. Let's hit accept. Maybe pick them one by one. We want to see temperature. Let's pick our top. Let's add a new one. TEC cold. And TEC hot. Let's hit accept. And let's click write to get our report. So this is going to show us new set of results where we can see the min, max, and mean temperatures on all these objects. So this actually concludes the presentation for today. Thank you so much for your interest.